Hello class. Today we will be going over section 8.5, use properties of trapezoids and kites. Turn to page 540 and look at number 3. Number 3 says points A, B, C, and D are the vertices of a quadrilateral. Determine whether A, B, C, D is a trapezoid. If you notice here, I looked at the GeoGebra website and I plot my 4 vertices. And I want to know if it is a trapezoid. So you need to read the definition of a trapezoid on page 536. After reading that definition, I know that a trapezoid is a quadrilateral with exactly one pair of parallel sides. That being said, I know that parallel sides have the same slope. So if you look at the diagram here, I can tell that side AD and side BC are parallel. And I know this because both of their slopes is negative 1.5. So since I have one pair of parallel sides, exactly one pair of parallel sides, that means that ABCD is a trapezoid. Look at number 5. Number 5, again, I plotted my 4 vertices on my GeoGebra website. And I looked at the slopes of the sides. So I noticed I have 4 totally different slopes. None of the slopes match. I have a slope of 0 here, a slope of 1.33 here, a slope of 0.25, and then I have a slope of 1.67. So since none of the slopes are the same, that means I do not have a pair of parallel sides. So ABC is not a trapezoid because there are no one pair of parallel sides. So since I do not have a pair of parallel sides, it is not a trapezoid. Look at the next one. Look at number 7. Number 7 says find the measure of angle J, measure angle L, and a measure angle M. So read the definition of isosceles trapezoid on page 537. Also read theorems 8.14 through 8.16. So if you look at number 7, if angle K is congruent to angle L, then the measure angle L is 50 degrees. Angle J is congruent to angle M. Now the definition of quadrilateral says that my interior angles equal 360. So I need to use that prior knowledge to help me figure out what is the measure angle JM. Now one thing I do know is I know they're both congruent. So I'm going to keep it very basic. Since I know that the total must be 360, I'm going to take 360 minus 50 again because these are congruent, and that equals 260 degrees. I also know that J and M are supposed to be congruent. Since I know they're supposed to be congruent, which is equal, I divide by 2 to get 130 degrees. So my measure angle J and angle M is 130 and L is 50. Now I can double check that by adding all the sides up and they should equal 360 degrees. Look at number 10. It says determine whether the quadrilateral is a trapezoid. Explain. Very, very tricky. So very important that you read those definitions and those theorems to get a good understanding as to why we have these different answers. So for number 10, I said it is a trapezoid. It's a trapezoid because I know for a fact that the measure angle C and D is congruent and angles A and B are congruent. I also know that angles A, B, C, and D are supplementary angles. And I know this by the consecutive interior angle theorem. Okay? So since I know that these angles are supplementary, and we know, think about consecutive interior angle theorem. When we talked about consecutive interior angle theorem, we talked about parallel lines and we talked about transversals. So if these are these are supplementary by this theorem. That means that these two lines, these two sides, sides AB and side CD, they must be parallel and they have to be cut by a transversal. So either way I look at it, they're cut by a transversal. But I can only have a transversal if the lines are parallel. So now I have exactly one pair of parallel sides. So since I have exactly one pair of parallel sides, that means it is a trapezoid. So go back and reread that definition again so you can understand this answer. 12, on the other hand, is very tricky. I see a pair of parallel sides, so I'm going to automatically say, okay, it's a trapezoid, but it's not a trapezoid. Angles M and K are congruent, but it also means that angle J and L are congruent. Because again, we talked about these supplementary angles by the consecutive interior angle theorem. If these two angles are 100, that means these two angles must be 80. And they're all going to be, all the pairs are going to be supplementary to each other by CIA theorem. So just reading the answer, it says because angle J and angle M and angle K and angle L are supplementary by the consecutive interior angle theorem. So angle J is congruent to angle L. So we know that since opposite angles are congruent and opposite sides are parallel, JKM is a parallelogram and not a trapezoid. So you need to go back and read over the definition of parallelogram. A parallelogram says that opposite sides are parallel. So that means I have two pairs of parallel sides. But let's think about the definition of trapezoid again. A trapezoid says it has to be exactly one pair of parallel sides, not two. So because this figure has two pairs of parallel sides and not one, it is not a trapezoid, it is a parallelogram. Also, another thing, you have to remember that on these diagrams, they don't mark everything for you. You have to mark things yourself. So if you was to remark this diagram, you have two pairs of congruent angles and you have two pairs of parallel sides. So if you notice on the picture, they didn't mark everything. So it's very important that you pay attention to the pictures. The pictures can be deceiving. Look at number 15. 15 says find the length of the mid-segment of a trapezoid, the trapezoids. So if you look at this, I need to read theorem 8.17, the mid-segment theorem of trapezoids. So once you read that theorem, we see the word mid, okay? We see that word mid. So when I see the word mid, that means I'm going to be dividing something by 2. If you notice on the way I worked out this problem, is very similar to the 8.17 model they use to do the calculation. So I use that model to help me do my calculations. If you notice here, I know that 57 plus 76 is 133. And to find the mid-segment, I have to take half of that number to get 66.5. And that's all you do. You add the two sides and then you divide by 2 to get your mid-segment. Going on to number 19. 19 says EFGH is a kite. Find the measure angle G. So we need to read the definition of a kite and theorem 8.18 and 8.19 on pages 539. So just pause the video for a moment and read those definitions. After reading those definitions, I know that by theorem 8.19, it says that if segment FG is congruent to segment GH, then the measure of angle F is congruent to the measure of angle H. So the measure of angle G, again, we know a kite falls into the quadrilateral family. So I know that the interior angles of a quadrilateral is equal to 360. So again, I'm going to use 360 as my total for my interior angles. And I'm going to subtract 60 minus 110. And I know this is also 110. So when I do all my calculations, I'll get 80. So you're looking at the angles of a kite, just know you're going to have 3 different angle measures for a kite. One of the one part of the kite, the angles are going to be the same, and the other two parts are going to have two totally different numbers. Look at 21. 21 says, use theorem 8.18 and the Pythagorean theorem to find the size of the kite. Write the lengths in simplest radical form. Pythagorean theorem. We know Pythagorean theorem is a squared plus b squared equals c squared. I know that c is the hypotenuse, and a and b represents the legs. So you think of a right triangle, you know you have to apply Pythagorean theorem. So you want to take a moment and read 8.18 and just remember how do you do the Pythagorean theorem. Going to theorem 8.18, after reading that, I know that segment XZ is perpendicular to segment WY. And segment WX is congruent to segment XY. Segment WZ is congruent to segment YZ. That being said, I'm going to take my two legs, which is 3 squared plus 3 squared, set it equal to my hypotenuse, which is WY squared. On this top part, it doesn't matter which triangle I pick because you're going to get the same answer. So I just chose the triangle at the top right. 9 plus 9 is 18. I want to break down 18, which is 2 times 3 times 3. I know that I have one pair of 3s, and 2 did not make a pair, so it stays under radical. So XY and WX is 3 square root 2. And remember, we do hypotenuse is always going to be your largest number. So if you type in 3 square root 2 and get the decimal answer, you'll see it is bigger than 3. Look at the next part. I see 3 squared plus 5 squared, which we have 9 and 25, and we're going to set it equal to YZ. 9 plus 25 is 34, equals to YZ squared. To get rid of that squared, I have to square root both sides. So I have YZ equals the square root of 34, which equal to WZ. If I was to break down 34, I would not find a pair. So this is my answer in its simplest radical form. Look at number 23 now. On 23, segment WY is perpendicular to segment XZ. So segment XY is congruent to YZ, and WX is congruent to WZ. And think about the definition of perpendicular again. We know perpendicular means I have two segments in this case that intersect and form right angles. So we know when we see the word, we see that notation perpendicular, we know we are forming right angles. If you look at this diagram, you have formed 4 right triangles as well. So we can do Pythagorean theorem again. So I'm working with my first right triangle at the top right, and I'm going to say 5 squared plus 10 squared equal XY squared. When I do my calculations here, I have 25 plus 100, which is 125. And if you notice here, I broke down a factor tree. I did a factor on the previous one, I just didn't show the steps, but I also did a factor on the previous step as well. I see a pair of 5, so it comes out of the root, and I don't see a pair here, so it stays in the root. So XY equals YZ equals 5 square root 5. Right here, I'm using this triangle here in the middle, my triangle at the bottom left. It doesn't matter which one I use, okay, because you're going to get the same answers. All the numbers are the same, so you get the same answer, but I'm going to use the one at the bottom. So I have 10 squared plus 19 squared equals WZ squared. So 100 plus 361 equals WZ squared. So 461 equals WZ to the second power. When I'm going to set both of these equal to each other, which equals the square root of 461. The divisibility rules is a great resource to help to see if you need to break down this number. If you know this is a big number, but if I look at my divisibility rules, I would see that this number would not break down. So my answer will only be the square root of 461. And it says simplify in the simplest, put it in the simplest radical form. So that's why I'm just going to leave it like this. And that is done. Look at 25. It says find the value of x. If I look at this diagram, I'm dealing with that mid segment again. So I want to apply theorem 8.17 to this particular problem. So if I apply this to the problem and I do my same little format, I know that 7 is my mid segment and it's equal to half of 10 plus 2x. Now my goal is to find x. So to find x, I'm going to multiply 2 on both sides. And the 2's here cancel out to 1. So I'm left with 2 times 7, which is 14, equals 10 plus 2x. 14 minus 10 is 2x. And 4 equals 2x. Divide 2 on both sides, so x is 2. So what would my answer be for this segment? Would it be a number bigger than 7, smaller than 7, or would it just be 7? What would it be? I'll let you think about that. Very, very simple, though. Going on to our next example, 34. 34 says, in the photograph of a chest of drawers, segment HC is the mid-segment of trapezoid ABDG. Segment GD is the mid-segment of trapezoid HCEF. AB is 13.9 centimeters, and GD is 50.5 centimeters. Find HC, then find FE. So they gave us a picture. Great help. So I know that HC is a mid-segment of these two parts here. Okay, this whole trapezoid. And I also know that GD is a mid-segment of only this part here. Okay, so again, HC is a mid-segment of only this part of my trapezoid, and GD is a mid-segment of this part of this trapezoid. So I have to find my missing pieces. Okay, so now looking at this, we're looking for the middle number. We're looking for a number in between our large and small number. So they gave me some information already. It says find AC first. I do want to start there because I need to start there to find FE. So to find AC, what I did was I know AB is 13.9 plus, and I know GD is 50.5. So if you notice, I did a little different from the two previous problems. I just kept it very basic. So when I add these up, I get 64.4, and I divide by 2 to get my mid segment, which will be 32.2 centimeters. So that would be my answer for HC. Okay. Now on this one, I did do a little bit more work on this one. So I have to find GD. So to find GD, I have HC, which is 32.2, and FE is what I'm looking for. Sorry, I'm looking for FE. And I have GD. So I know that it has to be a number bigger than GD, which is 50.5. So it has to be a number bigger than 50.5. So once I do my answer, I should be able to look at the number and see, does it make sense? Okay, so looking at this, I'm going to keep it pretty simple. I know for a fact that if I add HC plus FE and divide by 2, I get GD. I know that. So I know that's my form to find the mid segment. So we're going to keep it, we're going to do it like that to find out what this missing side is. That being said, I know that HC is 32.2 plus, I don't know FE, so I'm going to just say X there. Or you could have kept it as FE. And I do know it equals GD, which is 50.2. So when first thing I want to do is I want to multiply 2 on both sides of my equation. So multiply 2 on both sides of your equation here. And when I do that, I should get 50.2 times 2, which is 101. And I know here my 2's will cancel out. So I have 32.2 plus x equals 101. To get x by itself, I must subtract 32.2 on both sides of my equation. 101 minus 32.2 equals 68.8 centimeters, which is FE. And that does make sense because I know for a fact that whatever my answer is, it had to be bigger than 50.2. Okay, now go on to section 8.6. And on this one, if you notice, I didn't do a whole lot of work on this one. I didn't do a whole lot of work. I just looked at one part of this section, which is identify special quadrilaterals. So this is on page 546. And if you look at your book, it says copy the chart, put an X in the box if the shape always has the given property. So if you look at that, I already did the work for you. And this is something I really need you to study over because it'll be on your test. So you need to make sure you study. And it's very important. These special types of quadrilaterals, they have so many different definitions. So it is imperative that you study these vocabulary terms, these theorems, properties, everything. So you'll understand the different things going on with these different special type of quadrilaterals. So you all need to study.